The last unit that we're going to study for our semester is on systems of equations. And we're going to look at how you solve systems of equations, which are when you have more than one equation that you're dealing with. So make sure you put today's date in the top corner of your notes. So systems of equations are when you have two or more equations in the same variable. So a systems of equations generally looks like this. You'll have this bracket symbol, and you're going to have two equations that are listed. And your goal is going to be to find a solution for x comma y that makes the equation true for each equation. So the solution to a system of equations can be found two ways. Graphically, it's the point or the x comma y where two graphs intersect. So if you graph the two lines where they intersect is your solution. Algebraically, so solving it using properties from algebra, it's the point x comma y that makes both equations true. So when you plug in x and y, it makes both equations true or works for both equations. There are three types of solutions that you're going to see for systems of equations. First, you'll have intersecting lines. And that's going to look like where you just have two lines that are intersecting. And you have one solution at x comma y. So whatever the point is where they intersect, that's your solution. Other types are when you have parallel lines. Remember, parallel lines are lines that don't intersect. And in this situation, you'll have no solution. So to indicate no solution, you put a 0 with a line going through it. And the last type of solution you'll find is the same line. So the same line is when you're going to have a line that's overlapped. And to represent this, I'm going to draw the first line solid, and then the overlapping line dashed. And here is a special situation where you have an infinite solution, because every single point on the line works. And the symbol for infinity is kind of like that sideways 8. So for a system of equations, you're going to have 2 or more equations, and to find the solution to them, you're going to look at them graphically and figure out, is there one solution, no solution, or infinite solutions? Later on, we'll look at algebraically and how we can solve systems of equations using algebra. All right, let's look at some examples. Using the graphs that I gave you, place graph A into your notebook. We're going to label the equations from this graph, and then we're going to figure out the solution and where it intersects. All right, so when we're given 2 equations, and we want to figure out the system, we have to figure out each equation. So that's why we spent the last unit working pretty hard on graphing lines and understanding how to write the equations. So for this first equation, I'm going to add a dot there at 3 because I can tell that's the y-intercept. And it looks like the next coordinate that I can really use is actually this point that's down here. So the slope for this equation, I have to go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So the first equation is y equals negative 5 over 4, because I went down, x, and the y-intercept there is 3. For the second equation, I have the same idea. I put a dot where I can find it, and it looks like it's right there at the y-intercept. And the same thing with this one. The next coordinate is already labeled on the graph, so I have to go up 1 over 4. So this equation is y equals 1/4 x minus 3. So the solution to this system is the point where they intersect. So the solution here is 4, negative 2. Which means when I plug in 4 into each equation for x, the negative 2 should pop out. And that's how you solve a system of equations. You look for where, graphically, you look for where they're crossing on the graph. Let's try another example. This time, let's put in graph letter B that I gave to you. All right, same idea. We want to figure out the equations of the lines. So I'm going to plot the point that I can find on each line. So right there for the first line, I can see there's a point right there. And then again, it looks like the point here is where they're crossing. So I have to go down 4, 5, 1, 2, 3, 4. So this one again is y equals negative 5/4 x plus 3. But now for this equation, the point there is at negative 1, and I'm going down 1 over 4, so I also have negative 1/4 x again, and this time minus 1. So there's the system. The solution to this problem is 4, negative 2 again, which is a coincidence. It's the same answer, but this is the solution to this problem as well. If I plug in 4 to each of these problems, negative 2 should pop out. And that's finding the solution to a system of equations. So let's practice where I give you the equation, and now you have to graph it. So you're going to use the blank graphs that I gave you. All right, so this time, let's say I gave you the system, and we're going to graph it. So you're going to use one of the blank graphs that I provided. And this time I'm going to give you the system to graph. So the system, there are two equations here. Y equals negative 2x plus 4, and y equals negative x plus 1. So in order to find the solution, I have to graph both lines. I'm going to start with the y-intercept for the first one at 4, and I'm going to go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. I want to get as many points as I can because when you're graphing with the lines, you really want to have accurate lines to see where they're intersecting exactly on your graph. And the next line is negative x plus 1. So the y-intercept is at 1. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And this is why we wanted to get precise, because it gets a little challenging to see just exactly where they're crossing. So it's really important that you draw a nice, as many points as you can, because now I can see exactly where the two lines cross. It's at 3, negative 2. So the solution here is 3, negative 2. So when I plug in 3 into each equation, negative 2 should come out. Let's look at two more examples. So we're going to use another blank graph. Your system here that we're going to have to graph is y equals 1/2 x plus 2, and y equals 1/2 x minus 5. So graphing the first one, I put a dot at 2, and I go up 1 over 2, up 1 over 2, go in reverse, get as many points as you can that'll fit onto the line. Graph the second one as well. So I'm going up 1 over 2, up 1 over 2, and that's all I can really fit there. Okay, so for this graph, we have parallel lines. So when you have parallel lines, remember your solution, there is no solution. In order to have a solution, they have to cross. And one quick way to know that you have no solution is when you have the same slope, but different y-intercepts. That'll give you parallel lines. All right, and then using the last graph I gave you, so there should be 5 graphs altogether in your notebook today. We're going to graph our last system. Which will be y equals negative 2x plus 1, and y equals negative 2x plus 1. So when I graph this, I graph the y-intercept. I go down 2 over 1, down 2 over 1, go in reverse. All right, because these are the same line, I'd be graphing the same thing twice or on top of each other. So when you have the same line, your solution is infinite, which means everything works in this problem. And that's using graphing to solve systems of equations.